Good morning, students. We'll wait for 2 minutes and we'll start. Good morning, students. I am going to repeat the topic, the Hamming code parity bit. Okay, what is this actually? The normally, some of the student asked me to repeat this topic yesterday. Okay, for the exam. So instead of going to directly Hamming code, I will go with the sequence. Okay, I will make it fast. Don't worry about that. At the Hamming code, I will give a details. Okay, now I'm going fast. What is the actually error detection and correction? Okay, what is the error? Error is actually generated when we transmit some information, okay, from this place to another place, yeah, from one source to another. Like you have typed something in the WhatsApp and you have sent information. So because of good efficient work of this parity error bit, okay, you are whatever the message you are sending, the receiver is receiving the exact information. Okay, whereas if the error codes, okay, all this whatever the noise remover, if they are not efficient enough, you will not have the exact information what you actually want. Okay, because of the efficiency of this error detection, correction codes, noise removals, okay, we are getting a good information at the receiver part. So what is error? Error is which unwanted or some exchange in the information. Okay, that causes some miscalculation of the information. That is the error. How many types of error there in the digital? There are 2 to 3 types. Okay, what is that? One is single bit error, another multi-bit error, and the third one is a burst error. Okay, and multi-bit error and burst error are almost same. What is a single bit error? Single bit error is that only a single bit, whatever the sequence of bits are there, in there only a single bit is having some error. Error and it changed. Like you have sent 0 and you have received 1. Okay, that is a problem. What is actually the error? Like example, you have sent the information in this part 1 1 0. What is this? 6. But due to some 1 bit error, what happened? If 1 is replaced by 0, so 1 0. So actually what you have sent, but the receiving part got 2. Okay, so this may create some problems. This is a basic at the basic level, but if it the repetition of error happens at the last scale, what happens? It becomes difficult to decode the information. And the burst error is that not only a single bit, there are some sequence of bits are damaged. Like instead of 110, what we received 0 0 1. So what happens? This is a problem. We have sent 6, we received 1. This is a burst error. That is sequence of bits are changed. Okay, and what is the difference between the multi-bit error and the burst error is that in the multi error it means the changes can be happened at different places. Okay, like you can consider this example. You have sent 110, but the receiver what we got at the receiver we got as 0 1 1. Okay, only this bit and this bit has changed, and the one is as it is. Okay, you received 3. So what is that? Multi-bit error is there where multiple of time of error happens at different places or at single place. Okay, but burst error is that at single place 2 to 3, more than 2, yeah, more than 1 changes in the bit happens. Okay, so how we can remove this error? First of all, we have to detect where is the error, whether there is an error or not. Okay, so we have to do the detection part, then the correction part. The detection part can be done using single bit parity bit, 2D parity check, checksum, RCC. Okay, these are the things which help us in the detection part. Okay, there are also different type of, it is called as longitudinal check redundancy. Okay, redundancy check, longitudinal redundancy check is there, horizontal redundancy check is there. Okay, so different type of detections are there. So, but this whatever the codes are there, like say parity code, checksum code, check code, redundancy check code, this only works for detecting the error, but it cannot correct. The correction part was given by Hamming. Huh? The scientist Hamming, who has given the Hamming code to not only to detect the error, but also the correct the error. Okay. So this is a parity code. What is a parity code? The parity code is actually used for detecting the error. Okay, if there is any error or detection. But what is the advantage or disadvantage of parity code is that it can only detect a single bit error. Means if there is a single bit of error, then only we can detect. Okay, and another thing, what is the advantage is that here the parity bit along with the sequence code will send only a one parity bit. Why will send parity bit? This parity bit help us in detecting the error in the code. Okay, error in the sequence. This parity bit has actually help us in finding the error in the sequence. There are two types of parity bit, that is even parity and odd parity. Okay, what does this parity is do is, okay, it will check odd parity and even parity. So now we are going to see what is a even parity and odd parity. Like consider in the even parity, we have to see there should be even number of ones. If there is a even number of ones, okay, we'll send the parity bit as 0. Otherwise, if it is an odd number of ones, we'll send the parity bit as 1. See, with example, if I explain, you will come to know. Like consider, okay, sorry, give leave about this thing. You're sending a sequence as 1011. Okay, so what happened? You have sending the sequence as 1011. Oh, sorry, 1010. So 1010 is what? It is a even number of ones is there. Okay, so what we have to do after adding parity, if we are checking for even parity, then at last the even number of ones should be there in the sequence along with the parity bit. అంటే parity bit add చేసిన తర్వాత కూడా the sequence should be even number of ones. Here if you see there is 1010, so already it is a even number of ones. So to make it even, what we'll do, the parity bit, the p bit will add 0. So what happens, there are even number of ones only. Okay, now if suppose there is a odd number of ones, that is consider 1011. Okay, so there is odd number of ones, but it is a even parity. To make it even parity, what we will do, we will add 1. So what happens, 1 2 3 4, so it will become even. So what is the advantage of adding this parity? Let's check. This sequence, what is 10100, has been changed because when you are transmitting, there may be some error occurs. This noise can change the bit. So consider 1010, what happens, 1100. What happens, the second bit has changed from 0 to 1. Now what is this? This is the even parity. We are checking for even parity. Will give some information that we have sent the even parity bits. So 1 2 3 mood change and even number of ones unnaya ledu. Okay, there is a odd number of ones. So if there is a odd number of ones, it means there is a some error happened, because since it is a even parity, so even number of ones should be there at the receiving part, not only sending but at the receiving part also. But we are not received the same information because it is become from even to odd. So this is a error. Only the detection part can be done using this parity. Okay, like consider here after transmitting, we got in this way. It is a even parity, but if you see here, there is a 5 ones, that is a odd number of ones. It is a odd number of ones. So obviously we need an even parity, but there is a odd number of ones. So this is also there is also some error. So this way we actually calculate the error in the detect the error in the parity code. Whereas what is a odd parity? Odd parity means there is a odd number of ones. Like consider this part 0 1 0 1 1. Since odd parity is there, that is even odd number of ones is there, the parity bit we add as 0, because it will become what? Odd number of ones. Now suppose there is another bit sequence, that is 1010, then we'll add 1 here, because to make it is a odd parity, odd bit number. Okay, 1 1 1, 3 number of ones odd, so this is a odd parity. So detection is also same, like if suppose 1 0 1 1 1 వచ్చింది, parity bit change అయిపోయింది 1 0 1 1 1. So what is this? 1 2 3 4 4 ones ఉన్నాయి, 4 అంటే ఈవెన్ అనే వరకు ఏంది, ఇక్కడ యాక్చువల్లీ అవుట్ ప్యారిటీ నడుస్తుంది, బట్ యు గాట్ ఈవెన్ నెంబర్ ఆఫ్ వన్స్. సో దేర్ ఈస్ ఎ సమ్ ఎర్రర్ ఇన్ దిస్. Error means someone has changed it role from 0 to 1 or 1 to 0. Okay, so this is a odd parity. Okay, so now we know the odd parities. What is a even parity, odd parity? What is actually a parity bit generator? These parity bit generators actually detect whether their error or not, but to correct it we got a coding called Hamming code. The Hamming code has given some process through which we can calculate the error as well as we can correct that error. So what is the process for this? Let's see. RW Haram, okay, is basic. He given 7-bit Hamming code is used. 7-bit Hamming code is used. Okay, in this 7-bit, 4-bit is a data bit and 3 bits are parity bits. So how actually we calculated the parity bit? Since we know the data bits, by using these data bits and this reference formula, we are able to calculate the how many parity bits, information bits are required, which will help in correction the code. Okay, like if here is 4 data bits, so you substitute here, what will be there? 2 to the power of 4 greater than, okay, greater than or equal to p plus m is message signal, that is 4 plus 1. So what will get? P is the parity bit. We need to calculate the parity bit p. Okay, this is 2 to the power of p greater than equal to p plus 5. Okay, now we'll see hit and trailer. 3 is there, 3 means 2 to the power of 3 8. Okay, and 3 plus 5 8. So 8 is greater than or equal to 8. So 8 is possible, but to conclude to the 8 we'll check higher also. P to the power of 4, p to the power of 4 ante enta? P to the power of 4 is 16. 16 is greater than equal to p plus 5. p plus 5, 4 plus 5 9, ఇక్కడ 9 ఇక్కడ 16 వస్తుంది, ఇంకోటేమో 8 is equal to 8 వస్తుంది. So what we have to take? We have to take the least bits. Okay, so that's why we'll consider this part. So 2 to the power of 3 ante 3 parity bits మనం తీసుకుంటాం. So total how many bits required? 7 bits are required for the Hamming code to forward, okay, to correct the 4-bit data. Okay, and how this placement is given? 1 2 3 4 5 6 7. Okay, so this parity bit placement is given based on this formula, 2 to the power of p. Since parity bit enta 0 to 3 kada, so 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So 3 bits. Okay, so 2 to the power of 0 enta 1. So p1 దగ్గర parity bit ఉంటది, 2 to the power of 1 2. సో p2 దగ్గర parity bit ఉంటది, 2 to the power of 2, 2 to the power of 2 4. Okay, so how much we get? 4. So p4 place positions ఎట్లా క్యాలిక్యులేట్ చేస్తాం మనం? p to the power of p. Suppose 4 bit ఉంది అనుకోండి parity bit, then we'll get 2 to the power of 3. 2 to the power of 3 అంటే 8. So our next parity bit will be 2 to the power of p to the power of 8. Okay, this is the way we calculate the parity bits. So position of the parity bit p1, p2, p4. Since in mode fill అయిపోయినాయా, so remaining part is filled by the data bits, that is d3, d5, d6, d7. Okay, now we need to calculate the parities. Okay, calculate చేయాలి కదా, whether there is a detection or not, that we'll see later. First we need to generate the parity bit. So parity bit is given by the expression p1 is equal to d3 5 7 d7. Okay, and p2 is equal to d3 d6 d7, and p4 is d5 d6 d7. How we got? Just write the binary representation. What will be the 3 bits? Since parity is a 3 bits, so binary representation of 3 bits will be in this way. Okay, and 3 bits sequence 1, if you see here, it is started from p1. Okay, so if decimal, if you write, this is 0 1 2, this is 3. Okay, 2 ikkada 0 1 0. Okay, this is 3, this is 4, this is 5, this is 6, this is 7. Okay, now if you see here, this is p1, this is p1, this is p2, consider this is p4. Okay, p1 ఇక్కడ చూస్తే 1 3 5 7 దగ్గర 1 1 ఉంది. ఓకే, కానీ ఇక్కడ 1 ఎక్కడ రాసుకోలేము, ఎందుకంటే p1 ఇక్కడనే ఆల్రెడీ ఉంది. సో p1 దగ్గర కన్సిడర్ చేసుకుంటా d3 d5 d7. సో దిస్ ఇస్ d3 d5 d7. whereas p2 if you see, it is 3. Okay, this is 6, this is 5. Okay, 6 7 1 1 0. Okay, and this is 1 1. So what is there? d3 d6 d7, d3 d6 d7 వచ్చిందా? Okay, now coming to this part. In this part, if you see, okay, p4 ఎట్లా the parity bit ఉంది, so we cannot consider. 5 6 7 are ones, so d5 d6 d7. ఇది ఎట్లా వచ్చింది ఈక్వేషన్? ఏదో పట్టి కొట్టేది అవసరం లేదు. when you represent this in the form of binary sequence, okay, what is the table? 3-bit table. Okay, what happens? Wherever we'll see this p1 p2 p4. Okay, suppose ఇక్కడ 1 1 ఎక్కడ ఉన్నదో అది ఇక్కడ మనం ప్లేస్ చేసుకుందాం. ఓకే, ఇవన్నీ వచ్చేసిన తర్వాత మనం క్యాలిక్యులేట్ చేసుకోవాలి, వెదర్ దేర్ ఈస్ ఎ ప్యారిటీ బిట్ జనరేట్ చేయాలి. ఇప్పుడు we are going to generate the parity bits. How we are going to generate? D3 ఎంత, D3 ఎంత, D5 ఎంత, D7 ఎంత రాసుకోవాలి. సో అందుకని ఇది 1011 1011 అంటే విల్ ప్లేస్ హియర్ 1, దిస్ ఇస్ 0, ఇక్కడ నుంచి రాస్తున్నాం, దిస్ ఇస్ 1, D7 is 1, this is 0, this is 1 1. Okay, now we need to calculate the parity bit. సో ఇక్కడ మనం ప్లేస్ చేసాం, కన్సిడర్ దిస్ ఈజ్ ఈవెన్ ప్యారిటీ కదా, సో ప్యారిటీ బిట్ కూడా రాయాలి. సో D3 ఎంత ఉంది 1, D5 ఎంత ఉంది 1, D7 1 ఉంది. సో ఈవెన్ ప్యారిటీ కదా, కానీ ఇక్కడ 1 2 3 odd number of ones are there. So this parity, for this parity bit we'll add again 1, so it will make it as even parity. Okay, ఈవెన్ ప్యారిటీ. సో ప్యారిటీ బిట్ ఎంత రాసాం మనం, P1 కి 1 రాసాం, సో ఇక్కడ 1 రాసాం. నౌ D3 is 1, D6 0, D7 1, 1 2 3 2 are there, సో ఈవెన్ నంబర్ ఆఫ్ ఉంది ఆల్రెడీ. సో ప్యారిటీ బిట్ ఎంత రాస్తాం మనం, 0 రాస్తాం. సో P2 is 0, D5 ఎంత 1, D6 0. ఓకే, సో ఇక్కడ ఏం రాస్తాం మనం, ప్యారిటీ బిట్ ఎంత కావాలి 1 కావాలి, కాదు 0, బికాస్ ఈవెన్ నెంబర్ ఆఫ్ వన్స్ ఉంది కదా, సో 0. సో ద ప్యారిటీ బిట్ హియర్ ఇస్ 0. ఓకే, దిస్ ఈస్ అ జనరేటెడ్ ప్యారిటీ బిట్, generated and data sequence, everything is generated. Okay, this is the generation of Hamming code. Now what happens, we received something, okay, at the receiver point. We need to calculate whether there is an error in this. If so, correct it. So how we are going to do, we're going to do using this formula. B1 is equal to D5 D6 this is D5, this is D6, this is D7. P2 is equal to, కాదు ఇది రాదు, సారీ, this is D3, D5, D7. This is D3, D6, D7, and P4 is D5, D6, and this is D7. Okay, now we are going to see here whether there is a detect whether there is an error or not. It is even parity kada, so D3 enta 1, D5 is 1, D7 is 1, and what is the parity P1, 1, 1 2 3 4. There is an even number of ones, so there is no error, we'll write it as 0. Okay, now we'll calculate P2. P2 ante D3 ante enta 1, D6 is 1, D7 is 1, P2 enta 0. So it is odd number of ones, 1 3. So error enta 1 kada, to make it even. Okay, even generate చేయాలంటే ఇక్కడ 1 యాడ్ చేయాలా. Okay, so this is a error, there is a some error is there in this sequence. Okay, now again what happens, P4, D5 1, D6 1, D7 1. Okay, P4 is 0. So now what happens, again there is a error. So we have calculated that in these two sequence, P2 and P4 sequence, there is a error. So we need to calculate the exact position of that error. Position of error cheyalante etla cheyochu? Okay, to check the position of error, this error is there kada, ikkada error jo generate chesama adi binary represent lo chestam. Adi etla 1 1 0, P4 ఫస్ట్ వస్తుంది, P2 సెకండ్ వస్తుంది, P1 లాస్ట్ వస్తుంది. అంటే ఇట్లా రాసుకోవాలి, P4 P2 P1. The error of these three parity bits should be written. Now if you see, this is 110. This is, if you convert it in the decimal, it will be 6. Okay, so place here. So it means that there is error in the sixth position. It means that there is an error in the sixth position. So now what we do, since it is error, so it's supposed to be 0, it become 1. So we change this as 0. Okay, ఇప్పుడు మనం చేంజ్ చేసేసాం. Now we'll check whether the by changing this we are getting the correct answer or not. Okay, ఇక్కడ ఏముంది, D3 D6, D6 ఎంత, 0. Okay, and ఇక్కడ కూడా ఇది కూడా 0. Okay, since ఇక్కడ 2 ones ఉన్నాయి, so this there will be no error because it will become 0. Even number of zeros ones కదా, ఇది కూడా 0 అయిపోతుంది. Okay, there all are zeros, so it means there is a no error in the sequence. So by changing the only one error, whatever the we detected from the Hamming code, okay, we are able to correct the correction and we'll get the output as correct. Okay, this is the Hamming code. Any doubts regarding this? Ardhamainda? Anybody? రేపు 2 క్వశ్చన్స్ ఉన్నాయి. If all you got it, then I am going to the next topic. ఇంకా ఏమైనా టాపిక్ రిపీట్ చేయాలా? ఓకే, no doubts. Once explain, sir. Okay, once again explain, sir. I am going to explain again. Okay, only the Hamming code I am going to explain. What we actually do to generate a Hamming code is that, okay, suppose I will give it example. We calculate how many, suppose they have given a 4-bit. Okay, we need to calculate how many parity bits are required. Okay, these parity bits is calculate using this formula where the least, okay, should be the possibility. Okay, after this calculate we got 3 here. Okay, so there is total 7 bits are required, okay, to send the data, 4-bit data to, with the Hamming code. Okay, so what we have to do after this, we got how many bits need to be sent, but we need to calculate the position. So this position can be calculated using the formula 2 to the power of p. So this p is the position value we'll get. Okay, so there are 3, so we'll write 2 to 0, that is we should place the parity bit in the first position, to the power of 1, so we have to place in second position, and 2 to the power of 2. Okay, so this will should place at 4. So idu vacheshinda, this sequence we got P1 P2 P4 D3 D5 D6 D7. We have placed every bit, 4 message signals, data bits, and 3 parity bits. Now we need to calculate kada, ఇప్పుడు ప్రతి ఒక్క P1 కి P2 కి P3 కి సమ్ సీక్వెన్స్ ఉండాలి కదా, మనకు ప్యారిటీ ఎర్రర్ ఉందా లేదా చెక్ చేయడం. అది మనం ఎట్లా చెక్ చేస్తాం, బై యూజింగ్ దిస్ ఫార్ములా, దట్ ఈస్ P1 is D3 D5 D7, P2 is D3 D6 D7, P4 is D5 D6 D7. This how we got, why represent that, since parity is a 3-bit, with this 3-bit we represent 8 combinations. అదే 0 0 0 0. Okay, atla combinations lo the first one is P1, second one P2, okay, third one is P3. So this will give us information. Okay, ఎక్కడెక్కడ 1 ఉందో అది మనం ఇక్కడ ప్లేస్ చేసేస్తాం. ఓకే, p1 is equal to d3 d5 d7, p2 is equal to d3, actually it is represented in this way, d3 d5 7 ఉందా, ఇక్కడ is equal to కాదా, p1 d3 d5 d7, p2 d3 d6 d7, p4 d5 d6 d7 is equal to కాకుండా కానీ parity bit డిఫైన్ చేయాలని నేను is equal to రాసా. Now what we'll do, we'll place this part bits and we'll see whether we'll generate the parity. Okay, we'll generate the parity. How we are going to generate? See, actually fill చేద్దాం మనం. Okay, we need to calculate parity bit kada. By using this 4 bit we need to calculate the parity bit. How we are going to calculate? d3 enter, first ఇది place చేసాను, 1 0 1 1, so d3 enter 1, d4 d is 5 1, d7 1. This is a odd number of ones కానీ మనకి ఈవెన్ parity కదా. So to make the even, what we'll do, we'll add parity bit as 1 1 2 3 4 4 వచ్చిందా. సిన్స్ parity bit ఎంత 1 యాడ్ చేసామో ఇక్కడ 1 యాడ్ చేస్తాం. p2 లో ఎక్కడ, this is 1, this is 0, this is 1. Since it is odd number of ones, so we'll place 0 as a parity bit. So this is 0. ఇక్కడ d5 d6 is 1 0 1. So 1 0 1 అంటే ఈవెన్ నెంబర్ ఆఫ్ వన్స్, సో 0. సో p4 ఇట్లా మనం టోటల్ parity bit జనరేట్ చేస్తాం. ఓకే, now we have generated the parity bit, we have sent it the information, but at the receiver part we required we received in this form. Okay, 1 1 1 1. Now we have to check whether it is an error or not. How we are going to do? Same thing, p1 is equal to d3 d5 d7, p2 is equal to, సారీ మనం ఇక్కడ ఎప్పుడు కూడా p4 దగ్గర నుంచి స్టార్ట్ చేయాలి, దెన్ విల్ గెట్ కరెక్ట్ ఆన్సర్. p4 మీన్స్ d5 d6 d7, p2 is equal to d3 d6 d7, p1 is equal to d3 d5 d7. Okay, so we got all this. Now you check here, ఇక్కడ చెక్ చేస్తే d5 ఎంత ఉంది, 1 d6 1 d7 1. సో parity p4 ఎంత, 0. యాక్చువల్లీ ఇది ఈవెన్ parity కానీ వచ్చింది ఎంత, ఆడ్. సో we write here error is 1. Okay, this is parity. Now if you see here, all are ones, but the parity bit is p2 is 0. Okay, p2 is 0. ఇక్కడ కూడా చూస్తే 1 1 1 0, odd number of ones, so error is there, some error is there in, so we represent error 1. Now ఇక్కడ చెక్ చేస్తే 1 1 1 and parity p1 కూడా 1. So what happens, so even number of ones, so we'll write it as 0. So if you check the error, the sequence of error is in this way, 1 1 0 1 1 0. If you represent in the decimal, it is 6. The position 6 has an error. Okay, అంటే ఇక్కడ ఎర్రర్ ఉంది, ఇది చేంజ్ అయింది, so we'll change it from 1 to 0. Now after 0 we got the correct sequence. This is the process of Hamming code. Okay, okay, ఇంకా ఏమైనా డౌట్స్? Okay, you join again, once again we'll see the, ఇంకోసారి జాయిన్ అవ్వండి, అయిపోయిన టైం కదా, 1 minute అయిపోయినకి వస్తుంది, ఇంకోసారి జాయిన్ అయ్యండి, డీకోడర్ మనం కంప్లీట్ చేసేద్దాం. ఓకే, ఏం డౌట్స్ లేదు కదా ఇందులో హ్యామింగ్ కోడ్ లో?